All right, we're going to work through another example together on how to graph these. So again, most important thing, the first thing we want to look for is what's our new vertex. Original vertex is at 0, 0. If we look here, this is showing us where our vertex is moving. So what we're doing here, we're translating 3 units to the left. So again, keep in mind it's that +3, but you have to think about it backwards. So you're moving left, and then we're also moving one unit up. So our new vertex will be at -3, +1, since we're moving to the left and up. Now, they want you to work through by hand how to find some of these, and I'll put that on the PDF of the notes. But at this point, you really can just plug this into your calculator and find some other values yourself. So again, the key here, make sure you know how to find that vertex. So I'm going to plot it here at -3, +1. Make sure you pay attention to your scale, because these are going by 2s. So I've already plugged in my equation into my calculator. Again, very carefully about order of operations and making sure my parentheses are in the right place. And then once I open that table by hitting second graph, it opens a table of all of these values that are on my function. So some important ones that I found that I can graph. This is a good way to check to make sure you're inputting things correctly. So I found a coordinate at -7, +3. So that's up here. Got a coordinate at -5, 2. Here. At -1, 2. Here. And then at 3, 4 is another one. And I've got a couple more, but I've got enough here already. I think I can do a pretty decent job here of creating my graph. Now remember, these will be straight lines. This isn't a parabola, so those are supposed to be straight. Obviously, I didn't do a very good job with that. But those should be straight lines. Again, very important, making sure you're finding your vertex there at -3, 1. Again, those other values came straight from my calculator. Okay, so you are totally okay with doing that. So one more example here. So again, first thing we want to look for, we want to find that vertex. So we see that +6 and that +4. That tells me I'm moving to the left 6 and then up 4. So my new vertex would be at -6, +4. This is another time you have to be very careful with the scale. Okay, so this is now when you, again, want to plug some values into your calculator. This is one that actually looks really weird from what I recall. And I actually ended up, let's see, I got a couple coordinates here. I've got one at -1, +3. So that's going to be somewhere up here. And another coordinate at -11, +3. And you can graph as many as you want. Should just be giving you a picture here of what it looks like. And so it should be something like that. And there you have it. So again, those values come straight from your calculator, but you do for sure need to know how to find that vertex point. And it is part of your homework. You do need to include that vertex piece of it. So one other thing I want to briefly mention, you will need to discuss how the domain and range. Okay, so if you notice, domain, we're looking for the x values. So as we move horizontally left to right, we don't actually have any boundaries there. So our domain is just going to be from -infinity to infinity. We can use any x value here. Range, however, if we look now, if you notice, ours is switched now. So it's opening downward. So our lines here are going down forever. So in this case, our smallest y value is -infinity, but we do have a definite stopping point. Okay, and that's actually at our vertex. So in this case, our maximum y value is 4. So when it opens down like this, you'll have a maximum y value on your range. Versus a problem like this one, when it opens up, when we think about the range, since the function doesn't exist down at the bottom at all, it's going to have a definite lower bound, which will be at your vertex here, +1, and then goes up into +infinity. As usual, please email me with any questions. Good luck on your homework. Check out the PDF of these notes on Canvas.